we have gone through some of the factors. First was we have seen some of the properties of thermodynamics, whether it is a extensive property or intensive property. Then we have seen the cycle, process, path, path function, point function. Then we have studied also the heat transfer and work transfer. All right, and we have gone through a little bit amount of first law of thermodynamics. Okay, so based on that, I have plotted some of the questions. Let's find out that before starting this class. Okay. So you see in this question what they have asked. They have given in list 1, they have given the parameters, and in list 2, they have given the properties. Okay. Look into the properties carefully. Path function, point function, intensive property, extensive property. And we have to find out based on the score. They have 4 options they have given. Out of these 4 options, we have to find the correct one. Now, look into it very carefully. Now, we know volume is what kind of function? We know volume is our... Can you tell me what is a volume function?
It is dependent on mass, ma'am, directly.
Mass. That means dependent on mass means what?
Property. Extensive property.
Intensive.
It is the extensive property. Dependent of mass means extensive. Okay, extensive. Remember that. Okay. Remember, it is an extensive property. Not dependent on mass is an intensive property where it becomes pressure, temperature, density. Now you see the first option. A, we have the option 3. Now you see we have 4 options. Either it can be A or it can be B. All right. Now let's look into the work. Okay, what is a work? It is a path function. Am I right? What is work? Work is a path function. It is dependent only with respect to the process. Depends on the process, based on the process. Okay, that's why it is a path function. Now we have done this. Now we can automatically select. Now we have these 2 options, A and B. Now can we select? Now the last one also we got. Now can we say that B, C is also same? B, let's look into it. Density is also a intensive property, and pressure, we have the 4th point. Pressure is an C, we have the 4. Okay, sorry, I have made it wrongly. C, we have the 4. Okay. C, we have the 4. It is a point function. Pressure is also a point function. Alright. So we can say A is a right option. Did you get it? Alright. Moving to next. Now look into the first question over here. This one. Thermodynamics work is the product of. Thermodynamic work is the product of what? Okay, 2 intensive properties, 2 extensive properties, and intensive property and change in extensive property. So do you remember? We have wrote one formula like this. Okay, 3 dV integral. Right? Now what was the P? P was an intensive property, and dV, V means volume. Volume is an extensive property. dV means change in volume. That becomes an extensive property. Alright. Next. Now you tell me this answer for this question. Tell me the answer for this question. Here they have given assertive and reason. That means the statement, and for this statement, whether this is a true or not, or whether A and R is a different statement, how they're interconnected.
Option C, ma'am.
Option?
C. Option C.
Can you tell me why?
Heat and work are both inexact differential.
Exactly, that's very good because it is an inexact. We cannot differentiate. When we are differentiating, we should write W12. Okay? Integral of W12. We cannot write W1, W2 minus W1. We can't write it. Okay? Because it is inexact differentials. Very good. Okay? And what the statement they have said is completely true. It is cannot be expressed as a difference with the end state. End state means at the end points. That is the initial point 1 and the final point 2. Okay, it cannot be stated. It depends on process. Okay? And keep that in mind. Gate, whenever they ask a question, they will never ask, like, if any questions are there, you have to use two formulas. You always have to use two formulas. I guess we have solved one problem here. In this problem, right? The first one. Here you remember, first we have found out the volume. First we need to find out the volume. Then we are implementing on the existing formula. So always the gate follow the same trains. Did you get my point? Remember, always they follow this trains. You have to understand one of the parameter, you have to use some other parameter to obtain the value. And that given data will be provided on your question. Okay. Now moving to the next. Okay, next. Which of the
Excuse me,
following
ma'am.
is correct? Yes,
Can
please.
you just say the previous question alone once more, please?
Which previous question?
The previous question,
This one?
previous slide, ma'am. Yeah, yes, ma'am. The assertion and reason.
Yes. What do you want me to explain over here?
No, I just wanted to see it once more.
Okay, okay. Please. I hope it is clear to all of you.
Yes, ma'am. I got it, ma'am. I got it.
Whatever the others, drop in the chat box so I will know it is clear for all of you. So whenever anything you have doubt, you can always unmute and speak. Okay. Apart from that, I request all of you to mute yourself. And since I'm sharing the slides there, if you put in anything in the chat, I may not look into it. Maybe I will respond that in the after completion of the class. Okay. So shall I proceed?
Yes.
All right. Next, moving to next is which of the following is correct? The first one. Look into the first one first. Which of the following is correct? The cyclic integral of this, okay, of this for a process is. We have four options. Tell me the correct one. Tell me which one is correct.
Positive, ma'am.
We're now
Positive.
Unpredictable.
Okay, positive. Any other answer we have?
Unpredictable.
Unpredictable. Why? Okay, let me look into why positive. I think, tell me. I think Mohan has said.
Yes, ma'am. Actually, Because we see that the amount of heat that is being supplied to the system and then the work done, the difference of that is nothing but the internal energy, as we saw in the earlier session. So the internal energy is nothing but the energy that's being consumed by the molecules one. So that particular energy can be negative actually.
What is meant by cyclic here? Cyclic means what? That means integral
cyclic
of
means
dW equals to integral of dQ, isn't it? And can I write like this? Can I write like that? Can I?
yes, no.
Huh? See, the questions comes like that. Okay, you are going in some other level, but they ask from the basic. Try to understand the question. Okay.
Okay.
Some of you are telling negative, unpredictable, positive. Whenever they're giving any question, try to relate with some formulas. Okay, try to connect that with the formula. Now, what I have used, I know dq and dw is in first law of thermodynamics. Okay, now here we are much more easier. Now, in your question paper, they will have will be shuffled over there. Then that time you have to figure out from which topic they have asked a question. You should not take much time. Okay, so immediately you write up the formula and you just from here you will know it is just a zero. And one more point I have mentioned early, that whatever the functions or anything cyclic will be there, it has to be zero. I think I have mentioned in the early. Okay, keep that in mind. Now look into the next. Okay.
Option D, no?
Yes. Yes. This is again question of it is heat added and work done, which has to be equal to the change in internal energy. Alright. Now we have one problems. Okay. This is from the first law of thermodynamics. Okay. Now first read the question. During one cycle, the work fluid in an engine engages in two work interactions. Okay. In two work interactions. These are the 15 kilojoule to the fluid and 44 kilojoule from the fluid, and the three heat interactions of which are known: 75 kilojoule to the fluid and 40 kilojoule from the fluid. Evaluate the magnitude and direction of the third heat transfer. That means we have any random system. In the system, work has been there are two work done and three heat transfer. Now from here you have to analyze that what are the third heat transfer. Okay, how will you find? What is that mean? To the fluid. That means to the fluid means, can I say this is work done one is, okay, let me consider this 1 2 equals to 15. Can I write positive 5 or positive 15 or minus 15? Should I write plus 15 or minus 15?
Minus 15.
Minus, because it is work done to the fluid. Okay. Remember the term to the fluid, that means entering into the fluid. So we have minus kilojoule. Okay. Then we have from the fluid. That means it is leaving from the particular system, fluid system. That is plus 44 kilojoule. Let's consider this is 2 1. Okay. Then we have work heat transfer. heat interaction, the first one what we have is 75 kilojoule to the fluid. That means again it is entering. Again it is entering. Now this is Q12. It is positive or negative? It should be positive. 75 kilojoule positive. Second one from the fluid. Again it is leaving. Q23 is our, what is that value? 40 kilojoule. Okay. Now we have to find the third one. That is Q31. We have to find out its magnitude and direction. So when you initiate, you have to consider it is positive. That is Q31 is positive. Consider it is entering into the system. For an assumption. Okay, for an assumption, you have to consider this is a positive value. Now, as it have been said, it is a cyclic. What you do? Summation of work done, summation of the your heat transfer. Now you have to couple up with all the things. Minus 15, all are in the same unit. Look into the unit. 15 plus 44 equals to 75 plus 40. Whether it will be plus for 40 or minus 40, 2, 3 will be
Minus 4.
Minus 40.
minus 40. Okay. Plus Q31. Find out and tell me the answer what you're getting.
Minus 6 kilojoules.
Minus 6 kilojoule. Are you getting the same answer?
Heat is being
Now-
coming out of the fluid.
Yes, that means sometimes they can give the options like that. Okay, whether that means what is happening, it is coming out from the system. Okay, it is not in this way. In fact, it is coming out from the system. All right, from the system, heat system. Good. Yes. Now we will move to the applications of first law of thermodynamics. Okay? Now here it comes a very important topic. Steady flow energy equation. Steady flow energy equation, or we call it as an SFEE. Now the concept is very simple, just like as I've said, Bernoulli's principle. Here again, only to take care of that derivation part, but here you have to remember the final expression. You have to take care or remember the final expression. So here comes the final expression. You can see, I'm just blocking it. Okay. So you have to memorize this formula. You have to memorize this formula. Okay. This is the ultimate formula. This is the main formula. That is m dot 1. That is a mass flow rate, amount of mass flow rate entering inside the pipe. Okay. So U1. What is U1 here? What is U1? What is U1?
The internal energy.
Exactly. U1 is an internal energy. That is at the point 1. This is a point 1. And here we have the point 2. Okay. Entering is point 1. Leaving is point 2. So we are not looking into the what is the process undertaking over here. We are just seeing the when it's entering, what is the internal energy, and when leaving, what will be the internal energy. Okay. Then what is the P1? P1 is the pressure produced. What is V1?
The velocity at which it enters.
Yes, do not get confused with the velocity and volume. Okay, so when you write capital V like this, it is known as velocity, and when we make some kind of curve, that means it represents a volume. Okay, so you can do not get confused. Most of you get confused with the velocity and volume. Okay, so here will be deals with velocity here. Okay, remember we're dealing with the velocity. Then plus we have v1 square by v1 square by 2. That is again we are using the velocity plus z1. What is z1? Z1 is a datum line. That is at what height it is located. Okay. Here we have the datum line. That is a bottom line. You can see with the hatches. You can see with the hatches, right? And from this ground to that particular when the flow is entering, what is the distance? That is a datum line. So it is been represented as Z1. It is also known as a potential head. Potential head. Then here also it is leading. Now what happens in this system? Heat, when the heat is added into the system, that means it will come out in the form of work done. It will come out in the form of work done. That is as simple concept as it is. So here when we are multiplying this M dot, we are writing like dq by dt and power. That is the power or work done with respect to time. Okay, it is a dw by dt. Now this can be changed. We know based on the concept of enthalpy. Okay, based on the concept of enthalpy, what is enthalpy? H equals to U plus PV. Okay,
Excuse me,
enthalpy
ma'am.
is yes.
Why have you written Wx, ma'am? dWx by dt.
X, it is because along the x direction, there is
Okay.
nothing to worry with the x and y. This is all
Okay.
we are learning the uh, same. Okay, it is only one direction. Yeah,
Okay. Okay.
okay? Not multi-directional. So remember enthalpy. Okay, enthalpy is what is the property of enthalpy? It is an extensive property, and this enthalpy is the property of the system. Okay, remember this point. You can highlight that point. Enthalpy is the property of the system. All right. Now, what is the difference between capital H and small h? Small h represents it is a specific, let me write over here, specific enthalpy. Now, can you tell me what is a specific enthalpy? Whether it is an extensive property or intensive property? Whether it's extensive or intensive property?
Extensive property. Sorry.
Huh? Is an
Intensive property. Intensive property.
property. Remember when I have said whatever may be specific energy or specific enthalpy, okay, whatever it comes with the word it's specific with some kind of energy, it will be an intensive. Okay, specific volume, it is an intensive. Alright? Okay. Now you have to remember this. From that formula we have derived this formula, that is H1 plus V1 squared by 2 into 1000 plus G Z1 by 1000 plus heat added equals to H2 plus V2 squared by 2000 plus G Z2 by 1000 plus dW by dm. Okay. Yet they have divided the mass flow rate with the entire thing. So we have the only dW by d mass. Okay, we have the dW by d mass. Now you have to look into the question and its unit. Okay, if they have given the unit of H, okay, unit of H, or they have given the work done, or in terms of Q, they have given in terms of K, that is kilojoule. per kg, then you have to use this formula. If they have given the unit in terms of kilojoule per kg, that means you have to use this formula. And if they have given joule per kg, then you have to use this formula. Okay. Now, based on that, now we can implement on the various components of our any basic system. Maybe a boiler, if I consider condenser now, then you have that throttle, nozzle, diffusers, each and every kind of applications we can use the same formula. Now we will see one by one. First, we will look into the nozzle. Okay. Now, what is nozzle? Now, one more thing I would like to inform you that yesterday in fluid mechanics, when I was explaining about the Bernoulli's principle, okay? So I said about the convergent and divergent, right? I have explained about the convergent and divergent. Now, the principle when I have explained, keep that in mind. I have explained only for when the Mach number is less than 1. When the Mach number is less than 1. And today we had one more session. I hope many of you have watched that live or somebody were there, presents, you were present over there. So you have noticed there was some relation called pressure, velocity, area relation. You might have studied in your gas dynamics, pressure, velocity, area. That will explain you that why mostly when Mach number is less than 1, okay, less than 1, we prefer what are the impacts in the divergent and convergent. And if the Mach number is greater than 1, what are the impacts? So yesterday we have discussed is only on the Mach number less than 1. And that's why when we have Mach number less than 1 and convergent, we, we produce an increase in velocity, and that's what the example I have given. In gas turbine, they use a kind of convergent nozzle. Okay? But in case of rocket, okay, in case of rocket, obviously they use convergent, divergent. But if you look for other high-speed vehicles, consider the ramjet or the scramjet, if you look, what is the speed when they use a scramjet? They go more than Mach 1, 2, 5, 2 to 5. They can go, they can attempt. In scramjet, it can be even more, right? So they use divergent. Now, in case of when the Mach number is greater than 1, when the Mach number is greater than 1, what happens? It applies a different thing, that is V2 will be higher. And in this case, the pressure loss will be low. In this case, the pressure loss will be low. Alright, please keep that in mind. We will look into that also. We will come to that factor more. We will look into more closely. Okay? So please keep that in mind. Do not get confused. Whatever we have explained over there, that is only for subsonic speed. Now here we are talking about nozzle and diffuser. Okay, so again it is about the duct. We are talking about somehow either the duct can be convergent or divergent. It will depends only on how much amount of heat added or heat or work done by the system. Now here in the nozzle diffuser, this is one of the example.
We're now unmuted.
Diffuser in the nozzle and the diffuser. Okay. Now where the work is done, work can be only done in turbine and compressors. The work done, when we say work done, we can only say when we talk about in the turbine and the compressors. Keep that as a key note. Okay. So, alright. Now, if with the previous equation, this is the previous equation, if we don't have the heat and work done, when we put a zero and change in potential, because all are aligned in the same line. If I consider this is the cross section, okay, and I'm taking reference from here. Whether my slides is visible?
Mom, are you drawing something, mom?
Yeah, I'm drawing. Is it not visible?
I'm able to see a convergent and then divergent nozzle there. Mach number less
After
than 1
that,
and greater than.
I have explained about the next. It's not visible.
I could just see that I'm able to see the slide, mom, but the drawings in it, I'm not sure, mom.
What about the others? Can you see it? Let me know.
No, ma'am.
Nobody can see it. Is it visible now?
Mom, actually, the slide is visible, but the thing that you have drawn, I don't think. May I know what you have drawn lastly, mom?
I have drawn another convergent nozzle, and I've explained how the data, why we have written a statement, right? Change in potential energy. Now I have explained about that, why that change in potential energy is zero.
So the datum head is same you told, mom.
Yes, and I have shown a figure that why it is, no? To understand that.
In the right corner, mom, the top right corner.
And the bottom I have drawn here, there was a, just give me a minute.
Yes, mom, that is the one which I'm not able to see.
Is it a problem with you or if everyone? You can
Actually,
use
I
it
am not
chat
able to.
I also not visible.
Not visible.
Not
Not
visible.
visible, ma'am.
Just give me a moment. Just give me a moment. Hey, பொண்ணா, இது பிரச்சனை இருக்கு. என்னன்னா அந்த மார்னிங் இந்த பிரச்சனை ஆயிடுச்சு. அந்த திரும்ப திரும்ப ஸ்லைடு நான் எழுதும்போது அது இதாயிடுது. மீன்ஸ் என்ன சொல்றது, இட் இஸ் நாட் கெட்டிங் விசிபிள். எனக்கே விசிபிள் ஆகல. அடுத்து அடுத்து பார்க்கும்போது சொல்லும்போது நான் பார்த்தேன் அது விசிபிள் இல்லை. ஓகே, அது முக்கியம் இல்லை. இப்போ பாரு இது. You you enter here. Should I Google Meet? Huh? moment. I hope now it's visible.
You are now unmuted.
The slide is visible.
All right. See. So now here we have seen that we have said that it is a change in potential energy. Okay. Now how we can say this change in potential energy? Just consider it is a center line. It is a center line. This is the intake area, this is the exit area. Alright. So if I take a reference from here, and can I say that Z1 will be same as Z2. Can I say that? So that's why they say the change in potential energy is zero, considering this condition. But it's not necessary that always have to be zero. In case there is some inclination, then maybe you have something like this, right? Then your data line from here to here will be different. Here it is Z2, here it is Z1. Got it? But ensure that there won't be any heat added into the system, neither work done by the system. Okay? In nozzle and diffuser. So obviously, these terms will become zero. Now, when you substitute that, you will get this. Moving to the next. Next, we have the throttle. Okay? Throttle. Now, in the throttle, also we can see that there are also, as I've said, where the work done will be done only in the turbine and compressor. Work done, when we're considering, it will be done only on the turbine and compressor. Now again, throttle, these two parameters will be zero. And usually in the throttle, it is to be such a way that the datum line will be negotiable. That means again the Z1 and Z2 will be lying on the same line. And one more important point here, the kinetic energy is very low. That means V1 square by 2 equals to V2 square by 2. Okay. This will also be negotiable. Here, this 2 will also be negotiable. Remember, when you see the word throttle in the question, so you have to assume these are the parameters, and in that case, throttle, the enthalpy initially entering into the throttle and leaving will be same. That is another concept here. So usually in the throttle, enthalpy entering into the system and leaving into the system are same. All right. Now moving to the next, we have the turbine and compressor. Now turbine gets positive power output and compressor where we require the power input. So sometimes in the question they might write you in such a way that they want to find the power input or power output. So they may not use a term called turbine, they may not use a term called compressor. So they will just use the term as the power output and input. So power input means compressor, power output means your turbine. Now whenever there is a power input entering into the system, okay, so whenever there is entering into the system, it will be negative. Whenever, as we have said, any body, when it is entering into the system, it has to be what? Negative. The work will be negative. So you can see here, when we substitute in the basic formula, we are substituting the basic formula H1 equals to H2 minus, you can see the minus sign, minus dWx by dm. Okay. Now in case of turbine, it is a positive. It is coming out or work done by the system. Work done by the system. So it will be positive. Okay. Now we will go next. Based on that, similar way, heat exchanger. Okay. Now if you have any kind of heat exchanger, that means heat exchanger means you have a system. One place is there to cool air, place is there for that have the multiple inlets. When you have the multiple inlets, okay, in a heat exchanger, multiple inlets. So in that case, also the number of inlets, that means your formula will increase accordingly. The number of inlets, then your formula will increase accordingly. The mass flow rate of that inlet 1, inlet 2, 3, 4 will vary. Now talking about the condenser. Okay, condenser where the heat is added into the system. Condenser, or I can say boilers, right? So where the heat is added to the system. Okay, and where the heat is added, we cannot say the work is done. Okay, then the work will be zero. Heat is added. That means there will be the existence of the heat. So in your remaining equation, you have to ignore the work alone, and when you substitute that, you will get. The main concept over here you have to remember is that where we are taking the consideration, what kind of consideration we are taking, what are the assumptions we are taking. So in the nozzle, what I've said, there won't be any heat, no heat is added. Yes.
Can you explain condenser again, ma'am, please?
Yeah, I will come back. So nozzle means no heat is added. Nozzle or diffuser or duct. Okay? Or nozzle, diffuser or duct. In this condition, there won't be any heat transfer, nor the work will be done. That is the main concept. Next, moving to the throttle. Throttle, everything will just remember the enthalpy entering into the system, leaving into the system will be same. Leaving to the system will be same. Turbine is a place, turbine and compressor is a place where work will be into consideration. Work done will be into consideration. When we talk about turbine, it will be of positive, and in compressor it will be negative. And we have the heat exchanger. Then heat exchanger is same, only you will have the multiple amount of inlets. It depends on the number of inlets, just like how you solve a problem on your continuity equation. Similar fashion it will be done. Condenser is just like a boiler where heat will added into the system and no work will be done. Condenser here where heat get, and yes, boiler heat enters, condenser heat reject. Okay, that is the only difference. Now here what will happen here? You will get always when you substitute in the formula, you should get the answer in negative. Okay, the answer should be negative. That means it's rejecting or leaving out from the system. Okay, it is leaving out from the system. And when it enters, that is boiler, it will be added. So you should get a positive sign. Okay, clear? Now we will do a small problem based on that. So in this question, let's read the question. Air expands from 3 bar to 1 bar in a nozzle. Alright? Okay. The initial velocity is 90 meter per second. Initial temperature is 150 degree Celsius. Calculate the velocity of air at the exit of the nozzle. At the exit of the nozzle. So what are the factors given? T1, 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 T1. You have to find V2. You have to find V2. How will you find? Tell me the answer. I will get you the same formula. First, tell me which formula will you implement.
You are now unmuted.
And tell me which formula will you use.
H1 plus V1 square by 2 is equal to H2 plus V2 square by 2.
H1 plus
V1
V1 square by 2
2 equals to H2 plus.
plus V2 square by 2.
What is H1? How will you find H1?
You are now unmuted.
V1 V1.
H1 is?
U plus PV.
What is HF? H is enthalpy.
Ma'am, can we use Bernoulli's principle there, ma'am?
Yes.
Bernoulli's principle can we use there?
Find out.
P2. Hello?
During the exam time, you won't be knowing from where the question has come, right? So you can use whatever the laws you know, you can implement. Okay? So it is not necessary that you have to use this principle only.
For finding H, how to find U, ma'am?
Yes. So finding.
You have to find U
Yes,
for
yes.
finding
Am I audible? How will you find? That is my question. How will you find? What are the formulas you know?
It's like del Q minus del W is
They have
equal to
given
U.
temperature. They have given, put a note, they have given temperature. They have given one P1, P2. Let me give you a hint. Okay. is the formula. T2 by T1 equals to, T2 by T1 equals to P2 by T1 gamma minus 1 by gamma. It is an isentropic relation. It's an isentropic relation. Okay? It's an isentropic relation.
T2 is 306 Kelvin. No? So 306 degrees centigrade.
Which one? 300?
306 degrees centigrade. No? T2.
Oh, centigrade or Kelvin?
I've kept it in centigrade itself. No? If it's in Kelvin, it is 579 Kelvin.
I'm getting something else. What is a T2 you're getting?
309 Kelvin.
Yes, I'm getting the same. 309 Kelvin. Okay. 309 Kelvin.
It's actually 579 Kelvin.
How you've done? See, it is 150 centigrade. Now, if you want to convert in Kelvin to 73, so you will get 423. 423. Right? Now, T1 equals to 150 plus 273 equals to getting 423. Alright. Now, here it is an air expanded. Okay. So, you don't know the V1 and other parameters. So, let's take just give me a second. Now, T2, when you find, so what is T2 becomes T1 P2 by P1 gamma minus 1 by gamma becomes 0.286. Okay, 0. When you substitute the value of P2, it is 1 and here is 3 bar. No need to change the unit because it will get cancelled off. So I'm getting around 309 Kelvin. Alright. Now I know T1 and T2. I know T1 and T2. Our main motive to find exit. Now can I relate anything with that? Our main aim we know that is a formula H1 plus V1 square by 2 equals to H2 plus V2 square by. Now this is what we have to find out. Now from here we need to find out this H1 and H2. There is another formula of H, Cp of del T. Okay? That means del H equals to Cp del T. I hope all of you know this formula. Do you know this formula? Please note it down.
Unmuted.
Okay? That means if it is H1, Cp 1, H2, Cp 2. Now substitute over there. Now you have what is Cp value? Cp is 1.005 kilojoule kg Kelvin. Okay, kg Kelvin. Ensure that units again. Here we have kilojoule. So you have to convert the kilojoule into joule. Now let me know the answer. Tell me the answer.
For 87.2 more.
Are you getting the same 487 meter per second?
Yes. I
What about the
substituted
others?
pressure values now. Sorry, it was my mistake.
See, one more thing to take away points. See in this question, the question is only for 2 lines. But you see the calculation. You have done, first you have used isentropic formula. You have used isentropic relation. Second, you have used enthalpy relation. Okay. Finally, you have used steady flow energy equation. So same, likewise, they gave the question in your GATE examination. Now one more thing, keep that in mind, whenever they're asking the units, please look into the units very carefully. Look into the units very much carefully. Second, if they're asking about the number of decimal place, write down the decimal place correctly. Suppose they have asked for one decimal place and you have written, okay, one only, the 00 has no value. Even you have kept the value .00, that the computer might take error. Okay, they will consider it is a wrong answer. Okay, so keep that in mind. So if they ask for one decimal place, write for one decimal place only. If they have taken 2, write 2. 3, write the third one. Okay, because they will analyze your answer. It is a computerized method. Okay, so if you whatever the number of digit they have ask, give that number accordingly. Let's move to the next. Shall we move? All of you have found out the answer? Anybody felt difficulty? Aryan, Prakash, Registry.
Okay, we can proceed now.
Alright.
Yes, ma'am. Proceed, ma'am.
All right. Fine. Now we have one more question, and I think the similar kind of question they're asking each and every year in the TET. Okay, so now I will you solve this question and let me know the answer. Solve this question and let me know the answer. Read the question carefully. See, here they have given 3200 kilojoule per kg. Here also the same. Anybody have completed? Can use the chat box to answer.
Ma'am, it's D.
168.785.
Yes, yes, ma'am.
Please check your answer here. I got a different answer. Let me check with mine. Have you used this formula? How you got D? See what they have asked to find power output of the turbine. That means you have to see the unit. Megawatt. You have to find in terms of megawatt.
Excuse me, ma'am. The value of Q, ma'am.
Q will be 0. Turbine, see it is indicated turbine. What I said, turbine, it will be 0. No heat is added.
No, only work is done, correct?
So whatever the value we will get, I'm getting around this value is 607.84. I'm sure you're getting the same. And in GATE Aerospace, the same question we have repeated in 2012. Same question.
Ma'am, it's 12156.22.
12156. The answer you're telling it is in kilowatt. Am
It's
I
in
right?
yeah,
Kilowatt.
ma'am.
The
Kilowatt, ma'am.
answer, what is the
Megawatt.
answer? What they have asked? So when you're solving a problem, also you look into the time, how long time are you taking? Okay?
It's on 12.158.
Yes, 12.158.
12.158.
The point difference is not a big deal. Closest to the answer. The point fraction will get variance. It is not a big deal. Shall we move to the next? We have to complete the basic thermodynamics today, at least. Okay. Alright. Okay, we have, one more thing. Let me tell you. When we are considering a free expansion, okay, keep this point. Okay, this is also one of the key points. So whenever we are talking about free expansion, okay, free expansion, that means free expansion takes place in a vacuum, and where we consider the pressure is 0. In free expansion, the pressure gets 0. Okay? So if the pressure gets 0, then again it is a function of this. So if P is 0, that means what will happen to the work? Work will be 0. So keep this one as a key point. In free expansion, work transfer or work done will always be 0. Okay, you can put a important word. So that is it. Alright, next we have second law of thermodynamics. Okay? Second law of thermodynamics. So from here also you can expect a lot much of problems. Now what the second law of thermodynamics explains, it mostly explains, you can see the criterion as the probability of various process of heat transfer. So whether the heat will transfer from uh, high temperature to low temperature or the low temperature to high temperature. So there are a lot many possibilities and criteria that what it explains about that. So let's look into that one by one criteria. First, we look into the heat engine. Okay, heat engine. Now, what is a heat engine? First, we will have in the heat engine, we have the hot thermal reservoir, that is a source. Hot thermal reservoir, which is a source. Source means from where the heat is generated. Okay, or you can say the temperature is more. Then another source will be another place we call as a sink, where we have the low thermal reservoir. Low thermal reservoir. We can write as LTR. And when it transfer the heat from the source, let's consider a boiler. Okay, boiler. I hope you can see here the boiler. See the boiler. Boiler followed with turbine, condenser. Here we have the condenser where it rejects the heat. Boiler, which allows the heat to add in. Turbine, work done by the system. Pump, work is the input given. Okay, work is given in the input. Then this is how it goes on. Now when from the condenser the heat liberates outside, it moves to the low thermal reservoir. So this is the flow chart for an heat engine. This is a flow chart for the heat engine. So when the heat liberates out from this hot thermal reservoir, we consider Q1. It is this much amount of heat is given to the boiler, is supplied to the boiler, or we can say T1. It is temperature 1. Now, from the condenser, the heat is getting liberated. It is moving towards the low temperature or thermal reservoir. Either we consider as T2 or Q2. Okay. And in the pump, the work done into the pump and done by the turbine. Work done by the turbine. Alright. So if we have to find the efficiency, how we can find the efficiency of this engine? Always the efficiency is output by input. Always the efficiency is output by input. Okay. Then what is the output we are getting? Output is, can we say, the net work done. What is the net work done? The turbine work minus the pump. WT minus WP. And what is the input given? Input heat given is Q1. Now can I say that the net work done, that is WT minus WP, is equals to Q1 minus Q2, right? So using this relation, we get the thermal efficiency like this and this. Now here you have to remember the complete story. Whatever I have said the story, you have to remember this story. Now it will be helpful to understand or help you to solve the problem. Now here in any when the heat is added where in the boiler, okay, turbine, the work is done by the turbine. Condenser, where it liberates the heat. Pump, what will happen the pump? The work do will be into the pump. Okay, from the pump, work will done from the pump or into the pump, whatever it is. That means what is happening? It is entering into the system. This is the system: boiler, turbine, condenser, pump. This is our system. Okay, did you get the point? Now we have the heat engine. Now how the heat is added, where the heat is added in the boiler, liberating from the condenser, and pump, what is happening? It is work done into the pump, and by the pump or from the pump is a turbine. Now how to find the efficiency? Efficiency you can find using this relation, that is to first is a work output by heat input. Work output by heat input. Now work output means the difference of the work done by the turbine and minus from the pump, which is equivalent to the heat entered into the system minus rejected from the system. Okay. Now using the relation, this is the important expression that we have. This is a very, very, very important expression. Alright. Now, based on this, they will look into one problems. Okay. Now let's look into the problem. A thermodynamic cycle considering 4 processes. The heat and work are follows. Now they have given the Q, that is how much amount of heat is adding into the system, and what is W, work done, is this. Now from there we have to find what is the thermal energy of the cycle. Now whenever they are asking any question, I ask you to write down the formula. So this is how I remember. Efficiency means O by I. Now what is O here? O is a work output and input is heat input. Okay, heat input. Now using this relation, can you find out how much amount of work done has been done over here? How much amount of work has been done over here? Now substitute over here and you will get the answer. Now tell me what is the answer now.
One, ma'am.
One, how?
Means the work output is 5, ma'am. Heat input is 5. 5 by 5, it's 1.
Which option? It should satisfy this option, huh?
Uh,
We're now on music.
Option D.
Yes.
Option D.
D, 28.6.
28.6%. Yes.
How you got it?
One work output. So only plus 10 is considered. Plus 10.
Work output plus
Sorry,
10
one
is
mistake.
See, this is the biggest sin. This is the biggest sin. Anybody have found out the answer? Okay, let me take to the previous slide. Look into the formula carefully. Okay. Look into the formula carefully.
Answer is 0, ma'am.
0, how?
It's according to the formula, ma'am. Eta is equal to 1 minus Q2 by Q1. That formula I have used.
Look into the formula very carefully. What I have said, eta equals to net work output. Okay, net work output is total work done. That is summation of total work. Do you agree? That is 13 minus 8 will have around 5, whatever the unit. They have not given the unit. Okay, let it be. Let's consider the same unit. Alright. Now
Yes, ma'am.
divided by heat added. What is meant by added? That means
Ma'am,
entering.
option C, ma'am. 14.33.
It is 35. Okay, that means heat added. That is a heat adding Q1. Let's consider heat added is Q1. That is 35 because we will take the whichever is adding, not liberating. Minus means what? The heat is leaving out from the system. You got the point, all of you? So
Yes, ma'am.
heat negative means heat is liberating. Here we have heat is added. So when you solve that problem, what you get? I think 5, the other 35. What is the value you get? 5 divided by 35. How much?
14.28, ma'am.
14.33.
Yes, that means you get 0.1433 something. When we convert in percentage, we get as
0.14. Yes, ma'am.
0. Okay, something. So C is the right answer. Alright. So please, whenever you're doing some mistake, you learn from it. Okay. So now this is a learning phase. You are in the learning phase. Yet if you're doing mistake, it is understandable. Okay, but not in the final. Not in the final. So each and every time whenever
Hello, ma'am.
you do mistake,
Ma'am?
yes,
Ma'am, work output means it's the work done by the system, right? Means 3 plus 10, 13 only, no, ma'am.
it's a
Means
neat work.
minus 8 will be on the system, right?
No, this is a total, complete. What is the formula? You just see. Here, what we have done, net work output means what is added and what is leaving. Both we are combining. That's why we have got it, Abhijit.
Yes, ma'am.
Remember the points or the mistake you're doing. Alright, moving to next. Okay. Now this is also similar kind of problem. Okay, this is also similar kind of problem.
The thermal efficiency is 33%, ma'am.
Yes.
So it should be either option A or option D.
Okay. Okay. Let me tell you.
Work ratio, ma'am.
Work ratio is net work. This is the net work. Okay, net work done plus 1. Let's note down the formula.
I'm not able to see, ma'am, actually.
Screen is not sure.
I'm able to read
That means
W net plus W naught
work
by
ratio
W.
means, okay, note down. That is how much work is entered, okay, or given as an input, and how much is output. How much is input divided by output.
Ma'am, what is that, ma'am? W net plus WC. Ma'am,
Yes, input.
means WC means here, ma'am, in the compressor work. Okay.
Just give me a moment. I think the formula what I have noted is a wrong. Just give me some time to cross check once. Okay? Just give me a bit. Let me cross check once. Sorry. I've just written that by mistake. This is a need.
You are now unmuted.
Option B.
Yes.
Option B. Thermal efficiency is 66% and work ratio is 0.36.
How you have done? How you have done?
Hmm?
How you have done that?
The
Thermal
net work
efficiency is
divided by
Thermal efficiency is
200 upon 300.
first we have the this is a net.
Yes, ma'am.
This is
Option B, ma'am. Yes. 200 upon 300.
Compile everything divided by 300. And what is net work? Again, you have compiled everything divided by
W. Work done by turbine.
200 by 300.
you have to divide it by WT. T means what is the coming out? This is a WT.
550.
I didn't understand, ma'am. Can you tell it again, please? Ma'am? WT means, ma'am?
WT means how much amount of is work done by the system. Work done by the system.
Okay, the positive value.
Yes, positive values. Or you can symbolize like that. Work done by the system.
It's option D, ma'am.
D, right? You're getting 30.363 around something.
It's 33% and then option D, ma'am. 33% and then 0.36.
This one,
Yes, ma'am. Option D, I'm getting.
here you're getting, what is the value you're getting? Around 200 divided by 300. Am I right?
Yes, ma'am.
So you will get around 66. Isn't it?
Okay.
You got it?
Okay, okay.
Is my point? So understand that eta means
Yes.
net work done. Net work done, that means whatever the positive and negative you have to compile or the summation of the work done. Divided by heat added. Here only heat is adding. 0 means just ignore it. Whatever the heat is added. So when you substitute that, you will get 0.666 you are getting. So 66.7. Alright. So we have that only one option. That is 66. So you can directly say this is the right option without seeing anything. Okay. If there is another option with another parameters, then you have to look into that. Okay. So no need to waste much time once you have found out the eta value. Okay. So if the values are not different from each other, then you can go for that. All right. This is how you can save the time. All right. Now find for this one. First one. A reversible heat engine operating between hot and cold reservoir delivers a work output of 54 kJ while it rejects a heat of 66 kJ. Efficiency of this engine is. Again, it is a very easy question.
Option D, ma'am.
Yes.
We're now unmuted.
And D, 0.882.
0.8.
It's a very easy one. Okay. Okay. Now look into the next question. If the heat engine gives an amount output of 3 kilonewton, when the input is this much amount of joule, then the thermal efficiency of the engine will be. This is in kilowatt. This is they are given in joule. So you can also write this one as 10 kilowatt. What is watt? Joule per second is nothing but the watt.
We're now unmuted.
Option D, 30%.
Yes. Okay. Now we have some few statements, okay, Kelvin Planck statements of second law. So it is you have to remember the statements. Like we have Kelvin Planck statements. Then next we have Closier's statement of the second law. So you have to understand the statements. Okay, you have to memorize the statement. So what the statements are trying to say, let me brief you a bit. So it is impossible for a heat engine to produce net work in a complete cycle if it exchanges heat only with a body at a single fixed temperature. It says that if, let's consider we have two bodies, if there is some temperature 1 and temperature 2, then only it can transfer the heat. Whoever having the high temperature, okay, from high temperature, it will flow to the low temperature. But if the temperature is fixed, right? So what will be happening with the it cannot exchange the heat if the temperature is fixed. So such kind of body, okay, is not possible to find out what is amount of net work done. If the body is fixed, if they cannot able to transfer the heat from one body to another body, then it is difficult or it is impossible to have such kind of engine, okay, such kind of machine. Now next statement. Clausius statement of second law says it is impossible to construct a device which operating in a cycle which produces no effect other than transferring the heat from an colder to the hotter body. So they are going to discuss about the heat transfer effect from they are asking that it is not possible to construct, okay, without any effect. There will be some effect will be there if the body, any body has to transfer from the colder body to the hotter body. And here they have stated the two different bodies. One is the refrigerator and second one is a heat pump. So Clausius statement represents the refrigerator and the heat pump. We can write with HP. Okay? In short, we can write HP. Now, what it says that means it is completely violating which principle? It is violating your, or you can say it is just a reverse process of your heat engine. Now I will move to the next slide. Explain the refrigerator. Now look into the refrigerator. Okay. Now see, here we have the hot temperature reservoir. Bottom we have the low temperature reservoir. This is the refrigerator cycle. Now refrigerator cycle is our system. Now from the surrounding, the heat is, okay, from what we said, the heat is flowing from low to high. It is moving from low to high. Okay, so here Q2 it is adding, Q2 is adding into the system or entering into the system, and Q1 is leaving into the system. And the net result remains same. Whatever the net result, net work done, okay, net work done, the result is Q1 minus Q2. Now, in this case, we can find out the performance based on one coefficient. It's called as a coefficient of performance. In short, we can call as a COP, coefficient of performance. Now, it explains about the ratio between the desired effect, by work input, or we can say net work, or the net work done. So desired effect, when we can say, when we're talking about refrigerator, so all of you know that means it is moving from the low temperature to the high temperature. Okay? So what will be the desired? It is, that means we are moving from the cool temperature. It is moving from the cool. Refrigerator is to liberate the heat. So we will take Q2 minus what is work net, that is we can say Q1 minus Q2. Instead of Q, we can also write Q1 divided by Q1 minus Q2. So this is a formula you have to remember. Now COP, that is a coefficient of performance, this formula is constant. Now the desired effect based on the conditions it will vary. Now for the refrigerator, okay, the desired effect, because it is giving the cooling effect, okay, so that's why that is a desired effect. That's why we are putting Q2. Now what happens in a heat pump? Heat pump, also moves from the low thermal reservoir to the high thermal reservoir, but what it does, it liberates the environment a hot gas. Liberate a hot gas in the environment. That is, here we are talking about heating. In heat pump, we are talking about heating. So, to find out the coefficient of performance, here we will use Q1 divided by your net work done, Q net. The same Q net is same, that is Q1 minus Q2. Okay. Now, to compile this, you have to remember the heat pump and the refrigerator in terms of coefficient of performance. That is, heat pump is equal to the COP, that is the coefficient of performance of a refrigerator, plus 1. Now, from this relation, can you tell me whose coefficient of performance will be more? Whose coefficient of performance will be more?
Heat pump mode.
Yes? Not audible?
The refrigerator.
Refrigerator, why?
According to the formula, it is a heat pump which having the more
Heat pump.
coefficient of
Okay.
performance.
How you say that? How you can say?
It's seen from the formula itself. It's added by 1, so obviously when compared to
Yes.
refrigerator, heat pump
Yes,
having
absolutely. So this is the significant. So if the amount of heat here also it is liberating, but that is not a desired effect. That is not our as per the requirement. Okay. Here also we have Q1. Here also we have Q1. Just give me a second. Something popping up. Okay. Here also we have Q1. Here also we have Q2. Okay. Here also we have Q2. Right? But considering if both the parameters having same Q1 and Q2, but whether the COP, that is coefficient of performance, will be same? No. Always the COP of heat pump will be higher as compared with COP of refrigerator. Right? So this is another significant term. Okay. Now, relevant to this, we will have few problems. Okay. So here is one of the problem. So let me read the question. A refrigerating plant. So here they have used the word called refrigeration. Okay, refrigerating plant. That means they're talking about refrigerant. Okay. For a food store operating as an reserve Carnot reversed Carnot heat engine cycle, the store is to be maintained at a temperature of -5 degrees Celsius, and the heat transfer from the store to the cycle is at a rate of 5 kilowatt. If the heat is transferred from the cycle to the atmosphere at an temperature of 25 degrees Celsius, then calculate the power required to drive the power plant. So whenever they are giving the refrigerant, you just first quickly draw the rough sketch out of the plant. So here we have the low temperature zone. Okay, low temperature zone. Here we liberate Q2, that is a desired effect. This is a refrigerating cycle. Okay. Now here we have the your T1 or Q1. Here they have given temperature, so I am mentioning here T1, T2. Okay. This is T2. This is T2. This is Q2, Q1. I think then what they have given, that means this is our T2, T1. This is our Q, Q2. Now how to find the power? That is how much work done. That means how much work done. Okay. How you can find? Now let's recall what is COP. COP means desired by how much work done. Now what is desired? Here it is a cooled. That means Q2. That is I can say T1, T2 divided by T1 minus T2. Can I get this COP? Can I get this COP? In the same note, I can also say Q2 is given. Q2 is given. So I can write Q2 equals to NEAT. So can I equate this equation? We know the Q2 value, T1 value, T2 value, Q2 value is known. So from here I can find what is the W NEAT value. Can I? So solve the equation and let me know what is the answer you get.
Twenty kilometers.
How are you getting 20? See, one more thing. Are you getting 20?
T2 is 5, ma'am.
Keep that in mind. Then there is a degree Celsius. Okay? You have to convert the degree Celsius in terms of Kelvin. It's very important.
Okay, ma'am.
Degree Celsius in terms of Kelvin.
Ma'am, it's coming
2.367.
0.559 kilo.
0.56. You're not getting 0.56.
Yeah, ma'am, 5.03 into 10 power minus 4. It's like that 0.53 in. Ma'am, I'm getting, ma'am.
Are you getting 0.56 kilowatt?
Yes, ma'am.
Yes, ma'am.
That's great. All right. Okay. Now there are various features of reversible and irreversible features. Already I have mentioned over here. Now I would like to input one thing. What is meant by quasi-static process? Can anybody explain about what is meant by quasi-static process? What does it mean? Mostly in aeronautics, aerodynamics, and other things, we mostly use this word, quasi-static process. What does it mean, the word quasi-static?
Happening at a very constant and a slow rate process.
Exactly. When any process, whatever the process, whether it's expansion, contractions, it has to be with a very slow and gradual. Okay, it should have the gradual phase. So that particular phase we call as the quasi-static process. For an example, if anybody say like kind of jumping from first floor to ground floor, it is like a sudden process, jumping, right? And if they say that from the first floor to second floor, gradually using stairs, coming down, up, coming up, right? So that is called as a gradually it's increasing or decreasing. That is a quasi-static process. So here I have also highlighted in the notes. I have also provided you some of the highlighting points that you must remember. Okay. Now we will move to the third law of thermodynamics. Okay. So here they don't ask much question, but still you must know what we are trying to say. What is the statement? Okay. So here it says that it is impossible by any procedure, no matter how idealized, to reduce any system to an absolute zero of temperature in a finite number of operations. So can you tell me what is meant by absolute zero? Anyone?
Zero Kelvin.
Yes. What is absolute zero?
0 Kelvin.
Very good. At 0 Kelvin, that means whatever happens, it cannot, how much we idealize, maybe in the laboratory, however we do, it cannot reach below that. Okay? And can you tell me the reason why? Can you tell me why? Why we can't reach? Based on a microscopic level, the reason? So whenever we reach to a 0 degree Kelvin, what happens to the whatever the intermolecular systems? It stop. The kinetic energy almost gets zero. The kinetic energy almost gets zero. If there is no kinetic energy, then what will happen? That means you can't do anything with that. Okay. Always the whatever the value you get it should be above the absolute temperature. At least that means it should be above the 0 Kelvin. 0 Kelvin. That is the concept of the third one. We have some problems. Okay. Now another very important. Most of the time they are asking this question called Cauchy's theorem. Okay, it is also similar as a concept of entropy. So yesterday I think we were discussing about entropy. Entropy is that randomness. So whenever suppose any container is there and I'm heating from that water. Okay, if it is a n molecules of water, what will happen? The intermolecules will randomly move here and there. So for an entropy of a gas is always higher as compared with the liquid and followed with a solid. Now when we are talking about entropy, what is the property of the entropy? Whether it is intensive property or the extensive property.
It is a point function, ma'am. Am I right?
Yes, it is a point function, but I'm asking about what kind of property it is. I didn't ask about the function. Okay? Function, it is good. It is the point function. Keep that in mind. Yes, here I think I have mentioned somewhere. It is an exact differential, and also mentioned that it is a point function. It is a point function. It is a point function. That means when we are differentiating, it will be S2 minus S1. S2 minus S1. So whenever you are reading the property, remember, sorry,
Intensive.
it is an extensive. It is an extensive property. It is an extensive property. So this is the equation for that entropy. Okay. Now remember this again, the cyclic integral of the dq. dq, what is a dq? Change in heat with respect to time, temperature. For a reversible cycle, it will be 0. For a reversible cycle or the cyclic or the closed cycle, it will be 0. This is the formula. Remember the formula, and it having various states. That how it acts based on the different stages. Okay. First, we will look into the process when it is reversible and adiabatic. When it is in the reversible and adiabatic, what it happens. We will look into that. My PPT is intact, right? There is no issue with the PPT. Yes. Can you guys see the PPT? Can you see that slides?
Yes, ma'am. Yes, ma'am.
Alright, alright. Because here I was unable to see. So, so here we have many states. First is when the process is reversible and adiabatic. So adiabatic means when there is no heat is added into the system. Now when heat is not added in the system or 0, that particular point, what happens with the entropy? Entropy becomes constant. In that process, entropy becomes constant. Please keep that in mind when we'll go for the thermodynamical cycle for our gas turbine engines and all. This concept will again play a very important role. Okay? So where the entropy will be constant, where the other properties will become constant, that is a very important. So remember, whenever there is no heat is added or the adiabatic system, that particular point our entropy will be constant. This is an isentropic condition. Reversible and adiabatic means it is an isentropic condition. Isentropic condition. Now, okay, here I have written. Remember, it is an isentropic relation. Now, to find out what is amount of heat produced, how we can find when the graph will produce between the T versus change in S, that particular will be the our heat undertaken by that. Okay. So whenever we'll draw a graph between S versus T. Now sometimes instead of T, we can also draw with respect to enthalpy. Okay, we can also draw a graph between enthalpy, because how the enthalpy and temperature are connected. Again, H is equals to Tp into T. Remember this formula. And another formula is that U equals to CVT. What is U? Internal energy equals to CV into T, and H the enthalpy equals to Cp into T. Now, these are all the expressions. Now, main important is Clausius inequality. Now, Clausius inequality. This is a main important thing. What it says that the closed integral of dq by t should be less than or equal to 0. Okay? it is a less than and equal to 0. Now again, the cyclic integral of any property has to be 0. This is another important. So whenever any function which is relevant to a property of a system, so when we are integrating the particular system, then closed integral of that particular thing will come to the cyclic integral of any property will be 0. And entropy is a property. Okay. So here entropy is getting 0. There's one other key point. Remember the relation. So they used to ask a relation. And now we have this meaning of the significance of this relations. Okay. Now what is the significance of this relation? Now we have closed integral of dq by t that represents when it gets equivalent to 0, it means it is a reversible. Okay, it is a reversible. Now less than 0 means it is irreversible, but this cycle is a possible one. But if we get greater than 0, okay, if we get greater than 0, that means it first of all it violates the second law, and this is impossible. Now what kind of questions you can expect from here? Here you can expect like they will give you the question like choose the following options which will be violating the second law, or will be possible for the second law of thermodynamics. So there will be of lot many options, so you have to pick the right one. So if they ask the impossible one, so wherever there is a greater than, you have to choose that. Or they might give the question likewise, the closed integral of dq by t when it becomes greater than 0, whether it is possible, whether it will be 0 greater than 0, they can give the options like that. Now again another expression, it is important, this one. Okay, closed integral, what that means, that is actually it is a del x, it is change in entropy, that is an inequality of an irreversible process. Okay. And what happens in isolated system? If this we consider in an isolated system, our T isolated will be 0. Because this factor is 0. Because in isolated system, neither the heat is added nor the mass can transfer. Okay, neither the heat can transfer, neither energy can transfer, nor the mass can transfer. So if none of that can do, that means Q will become 0. If Q becomes 0, then you will get this expression. This is for the isolated system. Now you have any question? So for this, I think we have not made any MCQs. So yeah, then we have some kind of relations, combined relations, the first law and second law. We have to memorize these functions, combination of first law and second law. Okay. These are the formulas you have to remember. This is a combined formula. Now let me wind up the session over here. Now if you have any questions,